Hello all. Previously we have seen compilation process in C language. Now in this video we will see algorithms in computer programming. An algorithm is the step-by-step procedure which is used for solving a particular problem. In general, algorithms are everywhere in our real life. So for example, if we want to make a tea or coffee, there are some step-by-step procedure we need to follow so that we can perform tea or coffee preparation. So that step-by-step procedure is also known as algorithm. First we need to take a milk into vessel or bowl, and then we need to add some other ingredients so that we can perform tea or coffee, right? That procedure is also known as algorithm. We are using algorithms without knowing they are existing. So algorithms is a general term. Before writing any program, we should know what are step-by-step procedures so that we can perform a particular problem. So those are called algorithms. We should know the exact steps so that we can write programming better. So algorithms are general term in computer programming. If you want to take C or Java or C++, so you need to familiar with what algorithm we need to follow so that we can solve that particular task or a particular problem. So that is the meaning of what is an algorithm. There are some characteristics of algorithms. An algorithm should possess these characteristics. So we will see one by one. First one, finiteness. An algorithm must have a clear endpoint. It should terminate after a finite number of steps, ensuring it does not run indefinitely or infinitely. So an algorithm should stop at certain point. It should terminate after a finite number of steps. For example, if you boil the coffee or if you boil the milk continuously, the milk will evaporate, right? We cannot make a tea or coffee over there. So at a given particular point, we should stop the gas stove or something, right? That is called a finiteness. In programming also, a program should terminate after a finite number of steps. It does not run infinitely or indefinitely. So a algorithm must have a clear endpoint. That is the meaning of finiteness. So we'll see another point. Second point is definiteness. Each step of an algorithm must be precisely defined and unambiguous. So what is the meaning of unambiguous? It is clearly mentioned. Ambiguity means confusion. Unambiguous means no confusion. That is the meaning of unambiguous over here. An algorithm must be precisely defined and it is very clear. It should be very clear. There is no room for confusion about what should be done. So that is the meaning of definiteness. An algorithm should be clear and precise. So we will see another point, that is input. An algorithm can take 0 or more inputs, which are the data needed to perform its task. If you want to solve a particular problem, there must be some input. By taking input, we will process some calculations or we will process some data over the input, and after the process we have the output, right? So an algorithm can take 0 or more inputs where the data needed to perform its task. The input should be well defined and manageable within the algorithm's scope. For example, we need to take relevant inputs only. If you want to solve a average of a 3 numbers. So for average, what and all variables you need to take? First one, sum, because average of 3 numbers formula is addition of 3 numbers by number of terms. Number of terms means 3. That is the formula. So if we calculate product of 3 numbers, what is the use of product in average of 3 numbers? You are getting my point, right? We have to take relevant inputs so that we will have a better output. So that is called algorithm scope. So let us try to put it in more general way. Suppose we have to perform a recipe called omelette preparation. For omelette preparation, we will have some inputs. What are the inputs we have to take care in order to make an omelette? Egg and oil, some turmeric, some chili powder and some salt. What is the need of a coffee powder in making an omelette? That is irrelevant, right? So we need to take a relevant input so that our output will be better. That is called algorithm scope. It should be in algorithm scope, that a particular task scope. That is the meaning of input over here. And the next point is output. The algorithm must produce at least one output. which is the result of the computation or the solution to the problem. The next point is output. The algorithm must produce at least one output. That output should be meaningful and correct. For example, we are writing a one C program and we are compiling it. Suppose there are no errors in that particular program. Can we call it as program as a perfect problem? For example, let us take an example. If you are writing a prime number program, we don't have any compilation errors in that particular problem, and we are checking if it is correct or not. I have given 2. 2 is a prime number, it is showing. Well and good. I have given 3. 3 also prime number, it is also good. I have given 4 as input, and surprisingly 4 is a prime number, it is showing. It is showing 4 is a prime number, but 4 is not a prime number. Can we consider that output as a meaningful and correct? No, right? Even though we don't have any compilation errors, that doesn't mean our program is correct. There might be a logical errors. So our produced output should be meaningful and correct. Whatever we are expecting, that should come as output, right? So that is the meaning of output. So the next one is effectiveness. Each step of an algorithm must be basic enough to performed exactly and in a finite amount of time. So if you take an algorithm, it should finish in a finite amount of time, and it should perform exactly or precisely. That means it should produce a correct result. So in other words, algorithm should be run in short time. If you run a program in very short time, that means that that algorithm is effective. So we will see what is time and space complexity. In that you can understand what is an effective algorithm means. This is not the correct time to explain what is time and space complexity. In that you can understand what is an effective algorithm is. Okay. For now you just understood that algorithms should be run in a finite number of time or finite amount of time. Algorithm should be run in short amount of time, so that we can call that algorithm as a effective one. So these are the 5 characteristics of an algorithm. An algorithm must possess these 5 characteristics. One is finiteness, another one is definiteness, third one is input, fourth one is output, and fifth one is effectiveness. We will see some of the examples of algorithms so that you can understand it better. The first one is develop an algorithm to find the sum of two numbers. Suppose we have to find the sum of two numbers. What algorithm should we follow? First one, start. Step 2, input a comma b values. So we need to take 2 input values for a and b. In the third step, we need to calculate a plus b. Whatever the result, that result we need to store it in one variable called sum. We will see what variables in upcoming lectures. So no need to worry about what is a variable. So in simple terms, a variable is a memory location in which a value can be stored. So here sum is a variable. We are storing the result of a plus b over here. In step number 4, we are printing that sum. And step number 5, we are stopping the algorithm. Because an algorithm must stop at a given point of time, right? That is called finiteness, as we already seen in our previous slide. Once it is completed, we will see another example as well. In example 2, we are developing an algorithm to find the average of 3 numbers. So what and all, in order to find the average of 3 numbers, we need to take 3 input variables. First, step 1 is start. Step 2 is we need to input a comma b comma c values, and step number 3, we need to perform sum of these 3 values, right? So that is the happening in step 3. We are calculating a plus b plus c. The result we are storing it in sum variable. And in step number 4, we are calculating average by dividing sum by 3, because we are calculating average of 3 numbers. Suppose if we are calculating average of 4 numbers, we need to divide by 4. So we need to calculate sum, we need to divide it by 3, and whatever result we are storing it in average variable. In step number 5, we are printing that average value to the output screen. Step number 6, we are stopping the algorithm. This is the example for average of 3 numbers. In example 3, we are developing an algorithm to convert Celsius to Fahrenheit. How to do that? We are starting the program, or we are starting the algorithm, and we are inputting Celsius. We are taking an input for Celsius. And in step number 3, there is a formula called 9 by 5 into C plus 32. By using that formula, we are calculating Celsius to Fahrenheit. We are converting Celsius to Fahrenheit. We are calculating that this operation called 9 by 5 into C plus 32, whatever the result, that result is storing in F variable. On line number 4 or step number 4, we are printing that Fahrenheit value, and in step number 5, we are stopping that algorithm. These are the examples of algorithm. We will see in programmatical way so that you can understand it better in further lectures. I hope this session is useful. I will see in my next lecture. Thank you so much for watching.